All right, time to fly through a bunch of the concepts that are behind web maps. First of all, we're going to be talking about base maps. Base maps are basically the thing underneath this map. It's basically what you're looking at, excluding the items that are on it, like these labels and some of the streets and stuff like that. The base map is like our underlying layer. So here where we have Google Maps and it talks about layers, we've just changed the base map. If I now change it to be the terrain view, if I can change it, that's a slightly different base map. Something like the traffic is not a different base map. That's just different data placed on the map. But we have a lot of different base maps or tiled maps available depending what we're working in. In Leaflet, you can see here this one looks different. There's also a whole schwack of them, which we're going to go over in more detail here at this little Leaflet provider thing. You can see all these different base maps that are available underneath. They have different looks. Almost all base maps include the labels in them. It's very rare that you see one that doesn't have the labels. The Google Maps one looks like it's not including that because we can hover over it and it's interactive, but it's a bit of an illusion. Usually these are actually like rendered as part of the map itself. It's some kind of image that's being rendered here as we zoom in and out. So that gets me to the next thing, like what are these base maps? Like how is this appearing on my screen? What is it? Well, most of them nowadays work with something called tiling. You can actually see here, I don't know if you can see, I'll try zooming in on the camera, but you can see there's actually a little white line and you can see this little intersection here that seems to indicate that these are broken up into little squares, and that's exactly what's happening. Now, there are more complicated ways that things are done in modern web maps that aren't just loading pure images, but this is basically just loading a bunch of images depending on where you are zoomed on the Earth. It finds out where you are and how zoomed in and zoomed out you are, and it picks a certain image to load, a certain set of images to load based on where you are. So what do I mean? Well, if we go to this leaflet map that I've loaded up and we reload it, and I'm in this little network tab of my my dev tools, I can see all the requests to other resources that are being made. So for instance, if I loaded a logo from somewhere else, this would tell me, oh, here's the image that you loaded. So you can see there's all these PNGs that are loaded. So if we open one of these in a new tab, we see it's just one tile that kind of corresponds to this section of the map right there. There it is. Now, if I zoom out a whole bunch, and then I look at this again, I can see that it requested a whole bunch more tiles. So if I open up one of these now, it's like this. So it's, I don't know, like one of these sections somewhere. I don't even know where that is exactly on this little map, Jersey. So it's somewhere down here. Yeah, it's right down here. It's actually slightly off the map because it's loading some that aren't on the map so that when I zoom out a bit more, it's already there and there's no like lag in requesting it. So this is called tiling. This is generally how web maps work. Again, they find out where you are. That's all done by the library. You don't have to worry about that kind of thing. But it's somewhere on the internet, there's a huge folder of tons and tons of these different images, enough to account for the entire world. And depending where you are and how zoomed in you are, it grabs the right images and puts them into this specialized little container div and puts them in the right place so that your map looks like just a map. So that's pretty amazing. That's how that works. Now, I mentioned how important zooming is when it comes to maps. So zooming is obviously how it's an important part of this whole tiling process and this whole figuring out a base map thing. So zooming works sometimes on these discrete zoom levels, like you can see here. I'm just zooming out one click or one move of my mouse wheel, but it's the same as if I pressed in and out on these buttons. But then there's also Google Maps, which does zoom in and out in discrete amounts, but it's much smaller. It's a much smoother experience. And if we go to some Mapbox maps, if we go to the Mapbox Streets map, for instance, and we just look at this, there's even more smooth types of zooming. So we'll go preview style, and we'll see here that it still goes by discrete amounts, but it's very smooth in comparison. And it's not actually loading different images at every single time I move the zoom in and out. Whereas the leaflet one, it's loading totally different images every time. it works on a slightly different system. We're going to talk about it more, but some of that you just really don't even need to know until you're far, far more advanced in all of this. And even then, you probably don't ever really need to know it that much. But getting back to some more basics, we need to know a little bit about latitude and longitude. That's, combining with the zoom, the map needs to know, okay, what are the latitude and longitude of whatever you're looking at, or when we're adding things onto a map, we need to know latitudes and longitudes. Lots of time people get confused because they give me a list of addresses and they think that I can just put that on a map. But of course, our maps don't work by addresses, they work by latitudes and longitudes. Now, there's a lot of different ways that we represent latitudes and longitudes on maps. Generally, you can think of the Earth as, split into a bunch of circles that run north to south, so a bunch of lines that run north to south, and a bunch of lines that run east to west. So that's the grid that we've made out of the Earth in order to be able to tell you, oh, I'm at this line, and the intersection of those lines is called the latitude and longitude. You don't need to know a ton about them. They're pretty interesting historically, but that's because I'm a history nerd. But you can find a latitude and longitude by just going somewhere, like I look up Vancouver, and oh, it's saying I'm a bot. Okay, Vancouver, Canada. Is it going to say I'm a bot still? No, okay, it doesn't think I'm a bot. So then if I go to Vancouver, Canada, it's going to tell me the latitude and longitude, but it's the latitude and longitude actually of this exact spot, not of Vancouver in general. Vancouver in general doesn't have a latitude and longitude exactly. Every latitude and longitude is an exact spot on the Earth. The more decimals that you add to the end of it, the more exact it gets. There's a funny XKCD comic about this that I'll try to put in the links or on the screen now that just talks about how accurate it can get. You can get so accurate you're pointing to like a specific atom or something when you have a whole 10, 15 decimal places. So you're never really going to need much more than this. But it's also important to know that latitude and longitude aren't always given in the same order. Sometimes we give longitude and latitude, and sometimes we give latitude and longitude. We're going to see this when we actually get to working with these, that confusingly, there isn't actually a total standard for this. Also, the type of latitude and longitude that we use in web maps is a specific type of latitude and longitude, specific type of measurement. The same way we use Celsius and Fahrenheit or meters and feet, we use latitude and longitude sometimes in degrees, sometimes in meters, and sometimes the projection that we give, which is a fancy word that geographers use for like the system that we use to do the X and Y coordinates, sometimes they're different. So an important thing to know is that we have to get them into this particular type of latitude and longitude format, which is called, just so you know the name of it, it's called the Web Mercator system, or the Web Mercator, however you want to pronounce it, system. And it's just one specific type of projection. That's just a good word to know. Either as a geographer, you already know the heck out of projections, or you've never heard it before. And in both of those cases, I probably don't need to talk a ton more about it. You just need to know it's a thing. Okay, now getting back to just maps in general, we have two types of data that we're generally dealing with when it comes to maps. We call these raster data and vector data. And at the end, this basically boils down to two things. Our raster data is like pictures and images. If you think of a satellite map, it's a bunch of images. Or if we look at our leaflet thing, this underlying stuff is raster data. It's images. If I was to place a big image on the map here, that would be a raster data. So it can be a JPEG, a PNG, any kind of thing like that. Vector data is something that's made up of those latitude and longitude coordinates. So that might be a line, that might be a point, that might be a polygon. The reason that we distinguish those is that raster data, it obviously works a little different. You know, if you're zoomed way, way, way into the raster data, if I zoom far enough into the satellite map, it starts to get a little pixelated, right? Like that's just, eventually it does that because it's an actual image. But no matter how much I zoom into like a polygon or a line, it's never going to get pixelated. You can see here the road gets pixelated underneath, but the actual line is always smooth because it's made up of these latitude and longitude coordinates. If I don't have a very precise line, then it will be jagged, but it will never be like pixelated, because that's not the way that vector data works. It's always the same at every zoom level in terms of its precision, because it's just made up of different points. It's not a flat image. So hopefully that makes sense. Raster data, vector data. Finally, when it comes to web maps, we have to know that interaction is a big part of these. We have panning the map when we move it up and down and side to side. We have zooming the map when we move in and out. We sometimes have tilting the map. So I'm clicking around and stuff's happening. So if I press the 3D view, that's tilting the map. We also have rotating the map. That's another different thing. And finally, of course, we have actually clicking on something, and we have hovering over something, and we have anything else? I think that pretty much covers all our basic interactions. And we're going to be going over how to do these interactions, what are some important things to do when it comes to managing these types of interactions for users, but just important stuff to bear in mind. So that's a whole bunch of concepts just thrown at you at once. There's going to be some questions in the quiz section. If you're doing this on a platform that has quizzes or anything, try to get some of these concepts into you. You don't need to memorize all of them, but you got to get familiar with them, because in the next sections, we're just going to be moving along, and these concepts are going to be embedded in what we're doing. And this way you'll know what you're talking about if you talk to somebody else about web maps. See you in the next one.